Students. So I'm Keertana. I'll be handling now a session on IoT and its case studies. So let me first share my slide. Yes, I think my slide is visible. IoT. Okay. So when you abbreviate, you get a term called Internet of Things. So now I'll give the definition for IoT. Now IoT is nothing but a network. So a network can be static as well as dynamic. If it is dynamic, then I can say you can configure a network. Every device in a network will communicate, and for its communication it need to follow certain set of protocols. So to identify a device in a network, you need to assign an identity to a device. Okay, so generally a device in a network can be called as a thing. So every object in a network is called as a thing. And now a thing should not be ideal, right? So a thing should, you need to do some form of intelligence to a particular thing so that it can communicate with all the things in a network, so that every information from a device flows in a network, that is seamlessly. So now comes the complete definition of an IoT. So everything starts to communicate via a network. So you are making an thing to be a very intelligent in a network. So next, now we can see a diagram. So here you can see a device can communicate to any other device. So a person can communicate through a device to any device in a network. So anywhere, any place, any path, any network, any service, any business. Now there are some building blocks how we can achieve basic Internet of Things. So the basic thing is your IoT, and these things need a network to communicate, and the data can be stored in a cloud infrastructure, and through gateway the information can be shared to an external network. Yes, so some characteristic of devices which are in Internet of Things. The device should be dynamic. It should adapt to any form of network. It should configure itself, and it should use a protocol that makes it to communicate with other devices. Each device is identified by unique ID, and every device should be interoperable within a network. Yes, so first comes a definition for a device which is self-adapting. So each device should dynamically adapt with a network on which it is present. Example, let me take a device as a surveillance camera. Now here at day or night, the device should adapt itself. If it is a day, it should adapt itself as a normal mode, and if it's night, it should adapt to an infrared mode. Okay, and if any motion is detected, it should convert to high resolution mode, and there is no motion, then it will convert to low resolution mode. So now my camera is said to be self-adaptable based on its surroundings. Next, self-configure. So you don't have a single device in a network, right? So you have many devices within a network. So each device should self-configure itself based on its functionality. So like example, I have weather monitoring. So the device should be able to configure itself. So like if it is summer, it should need to sense, and then it need to configure to that weather. Okay, so if it is winter, it need to monitor its surroundings, and it need to set up a network. It need to fetch the information, and the device should be said to be automatic. Okay, so it should be self-configured to its external environment. And next one, it should be interoperable. Is already said you don't have a single device, you have many devices, so each device should communicate with each other, as well as the device should communicate with the infrastructure, devices which are present in the infrastructure. Next is unique ID. Yeah, every device is identified by its ID. Now I can say an identifier to be address. Okay, like I can have a unique resource identifier, or for a network I can have an IP address. Now a device is made intelligent. Okay, when you say a device to be intelligent, it should adapt based on its surrounding. It should communicate with other devices, and even if the users query a device, okay, it need to monitor its status and then control them. So it should be controlled by users who are present remotely. Okay, now next, it should be integrated to information network. So we already have an existing backbone network. Now, any device which fetches the data should communicate the data to a backbone network also. Okay. So now see here, I have a weather monitoring nodes. So it monitors weather, communicate and exchange the data. Now that data need to be transferred to a some centralized server where the particular data can be predicted. Okay, can be predicted for further analysis. Okay, now I could say a basic IoT infrastructure may have two things. One is things and another one is protocol. But the main role is played by an object or unique identifier or things. Okay, now see here, I could have an IoT devices. So here there are some few examples like smartphones, wearables, voice assistants, fashion, hearables. And you also have certain home IoT devices like see the examples like smart plugs, meters, chargers, lightning, entertainment devices. So every data is stored in the cloud, and from cloud the data can be further processed to a remote device. Yes, so just let me give a basic definition of thing. A thing refers to an IoT device. So each thing, as I already said, you are given with a unique ID, and a thing can sense the environment. It can be actuated. There is example motoring or relay action, and then it can continuously even monitor the surroundings. So now, whenever a device collects its data, okay, exchange the data with another connected device, or the device can collect the data from other device, and it can send the data to server. Okay, it can send the data to server, or it can even perform the data locally. It can even do anything with the data locally. Okay, so now this is a generic block diagram of an IoT device. So an IoT device should have these few blocks. So connectivity. So you need to connect this through an USB or Ethernet cable to external network. You need to store the data. So you need to have a processing, okay, processor, memory. Okay, for graphic processing, you need to have a graphic processor unit. For storage, you can have a memory and audio video interfaces. And I also have certain serial and parallel communication protocols for communicating with other devices. So now for connecting devices to human value. Okay. So see device connection and connectivity. Then it sends the data, and the data is transported, and you can analyze the data and define data. You can define the data by some action. Okay. And even by using apps. So in mobile phone you can install an app and you can monitor the device, okay, which is present on any household. Okay, and a simple example is you can switch on or off your fan through an app. Okay, or you can switch on and off a light through an app. Okay, so this is an example of an IoT. So here they have listed the functions of each method as a cycle in an IoT. Okay, so let me just share some few examples as some case studies. Okay. So here some few examples I'll share. First one is weather monitoring, and here is a simple block diagram. Okay, so now see here the IoT device. Okay, here I have used many sensors like the temperature, humidity, pressure. So here it measures or monitors the surrounding, and the data is processed. So message queuing telemetry. Okay, it's a protocol that it uses for transferring. Okay, so the code will send to server, and the server find this weather data can be again viewed as a graph. Okay, in an app through a mobile phone. So it can also be shared as a web page, so anyone can access the web page. Next example I have is okay, for same weather monitoring. So see here the data can be shared to more than one devices. Okay, so for weather monitoring they have used a temperature or a humidity sensor. And next comes an example of smart irrigation. Now see here I have a Raspberry Pi board. Now here for measuring for smart agriculture, I could have soil moisture. To measure the moisture level, I use the soil moisture sensor. And for measuring temperature or water level, humidity of water level, I use two sensors. And you need to see for every sensor node, you need to back up with some battery, right? So and then so based on the measured value, the pump can be turned, so relays a switch which turns on or off a water pump. Okay, and the same data can be shared to a cloud which can be viewed as a mobile app. Okay, next is your next type of example. Okay, this is the same real-time example for a smart irrigation. So I place a sensor everywhere, and this sensor will monitor your soil moisture, and the data can be transferred to cloud through a mobile app. And here remotely can control the amount of water level that can be poured for agriculture. Okay, next is forest fire. Okay, so now here the main sensor is CO. Okay, carbon monoxide, because once it fires, it releases a carbon monoxide in air. So CO sensor will monitor the carbon monoxide and temperature also, right? If a normal air temperature, if it exceeds certain value of normal air temperature, then this sensor should monitor the temperature. And then this is again sent to Raspberry Pi for further processing. So based on that, the alarm can be turned on or off, and same the data can be shared through cloud to a mobile app. Okay, and okay, now this is a simple schematic of a forest fire reduction. Now we can see if there is some fire. Okay, so here I have many sensor nodes, and each sensor will communicate within a network. Okay, now this forms a simple network architecture. Now if there is some fire, okay, so this node will communicate to a nearby sensor node and through a gateway. So there will be a centralized node too. Okay, the centralized node will communicate to a gateway through a cloud to a, and the message can be viewed on a smartphone or tablet. Okay. Now, yes, so these are some few examples. We have seen like weather monitoring, smart irrigation, and forest fire reduction. So, Internet of Things does not limit to this. Okay, you can have many application where you can interconnect every real-time things to a real world. Okay, where both human and things can get benefited. Okay, instead of just being physically present everywhere, we can remotely monitor the activity or things or control. Instead of a sudden panic that you can experience, you can just go, instead of going to a nearby place, you can remotely control the things. And this IoT, you can like you can use it where the human in areas where human are inaccessible, right? You can just spray a sensor node inside a forest using an aeroplane, and each sensor node, once battery level is gone, it is dead, right? It is dead. So once it is active, you can continuously monitor the environmental changes. Okay, so IoT will pave a way for future research community too. Okay, so thank you for your patient listening.